In this video, we will discuss about detailed study of soil investigation report. In this video contains necessity of soil investigation, methods of soil investigation, discussion on plate load test, discussion on soil subgrade modulus, concept of settlement uniform and non-uniform, detailed study on soil investigation report.
In our last session, from today's session, we have to keep our discussion as continue for the next topic as the methods of the soil exploration. Okay, like as we have learned, it is very important to do the soil investigation for the proposed work, okay, for the proposed land. Unless you are not doing the soil exploration, you will not have the idea of this soil behavior, soil properties, soil nature, how your soil is going to behave in respect of your applied load. If your load is what adequate, it's normal load. If your load is high, okay, if your load is what point load, aerial load you are going to implement over the land, so in that situation your soil mass, how it is going to respond. So it is very important to understand, and that is only possible by the soil exploration. So different methods are actually available to investigate the soil. So purpose is very clear. We have to know the what is the capacity of the soil, first thing. Second thing, we have to ensure that whatever the load we are going to put over the soil, whether our existing soil is capable to bear that load or not. And the third case is what, if your capacity is not enough to carry the load, in that situation what will be the remedial measures. So to suggest all that things, what is the existing capacity of the soil, first thing. Second, what is the settlement possibilities are there, whether the load that existing soil can carry or not. Okay, whether the structure that you are planning to build over the soil, whether the soil is capable for that or not. Okay, what type of foundation will be suitable, either shallow foundation, either deep foundation, what type of foundation will be suitable for the land. Okay, what is the level of the water, whether it is close to the ground surface, whether it is at a greater depth to from the ground level. So to investigate all that things, we need to do the soil exploration. So purpose is very simple, but there are different options to perform the soil exploration. Means different methods are there, and based on the situation, a situation what it will include, situation will include actually the type of the project, what importance you are going to give the to the project. When the project is not that much important, so you can choose the option of soil exploration that will doesn't demand to invest more cost, because soil exploration will is actually costly. So in respect of the importance of your project, accordingly we are going to choose the method of the exploration. If you are going to build a very iconic structure, very important structure, very tall structure, in that situation we are going to give the more importance. In that situation we are going to do the exploration accordingly. Like suppose if you are going to deal with the simple structure, okay, that is not having that much importance, so what I can do this simple on-site testing. But if suppose I am going to deal with the suppose on-site testing, okay, I will take a sample from a test pit. I will discuss what does mean the test pit. So I will collect the sample from the test pit, and then I will carry that sample in the laboratory and I will do the testing in the laboratory. So that is more economical than that of the doing the test on site after setting out lot of things. So in that situation, doing the testing in laboratory is the easiest one, it is the economical one, so I will do that. But if you are going to deal with a very big project, very important project, a very iconic project, if suppose you are going to build, and in that situation if there is a demand to do the exploration with a more precision at multiple points at a greater depth, it is needed to do the exploration either on site as well as on laboratory. So both investigation is needed to do to get the real solution, to get the right capacity, right properties of the soil. So based on the project and its importance, the method of the exploration is going to be adopted by the geotechnical engineers. The number of the points where we have to do the exploration, that also going to be decided based on the importance of the project. When the project is not that much important, then one and two boreholes, one and two test pits are going to be chosen. But when the big project is there, when you have to cover very large area, in that situation you have to choose the number of boreholes, you need to choose the number of test pits. So this is what all depends on the importance of the project. So my dear friend, there are many methods are actually available. There are a lot of theories and things needed to understand, but we are trying to discuss some important things that is what required for our study. So very first thing, where for every project, as the geotechnical engineer is going to adopt, is your visual inspection. It's quite obvious. If suppose you are going to assign for any project, so what you will do, you are going to do the visual inspection, whether at the ground level the water is present or not, what is the condition of the soil at the ground level, and thereafter what vegetation, okay, and greenery around your proposed land, what is the situation by the physical observation where is going to be noted by the geotechnical engineer. And based on that visual inspection, they are planning to do the on-site testing, or they are planning to do the laboratory testing. And what method should be adopted based on the convenient, based on the economical consideration, okay, and based on the importance of the structure. Based on all of that things, after the visual inspection, the geotechnical engineers are deciding what method should be adopted. And in that, if the structure is not that much important, the most common is what? Test pits. What? In simple, we are going to do the excavation on site to a some depth, and we are finding by the visualization, we are finding the hard strata. And wherever the hard strata we are getting, at that level we are going to do the two things: either you can do the on-site testing, and or you can take the sample. After collecting of that sample, you can take in the laboratory and you can do the soil testing. So first is the visual inspection, second is what? Test pit. If suppose you are going to adopt, if the structure is not that much important and you are not willing to go for greater depth, structure is what going to impose adequate anticipated load. Like suppose you are going to build a residential building, and suppose it is G plus 3 4 floor building, and ground is also having the adequate strength. So what we have to go just for the 2 to 3 meter deep, and at 2 to 3 meter depth, we will get our hard strata. So at that depth, and if suppose you are assigned to do the investigation, what you can perform the test on that depth, that will become your on-site testing. And the best option, which is most commonly adopted, is your plate load test. On that test pit, if suppose you are planning to do the site investigation, okay, so there is the best option is to do the plate load test. What does mean the plate load test? I will discuss it after time. Okay, so here, and another is what? Taking the sample from the land, and we are taking into the laboratory and performing the test, and getting the required parameters and required properties of the soil. Then second, soil borings, cone penetration test, standard penetration test. So they are almost same, just to find out the grain size, just to find out the hardness of the soil, and that is to find out the moisture content of the soil. Okay, and if suppose you want to do the study by layer to layer in a greater depth, in that situation we are going to do the soil borings, we are going to do the standard penetration test. Okay, so in that situation, what we are collecting the sample, like see the soil sample through the boring, and these samples were going to be collected in the laboratory, and the test is going to be performed. Okay, so this is the another method. Thereafter is what? There is a standard penetration test. There what? We are going to find out the stiffness of the soil and density of the soil, we are going to find out. So what we are going to do, we are going to drop a weight over the soil, and we are going to hammering over that, and we are counting the how many number of blows are required to do that borehole and putting that drills. So we are actually finding what stresses, what number of pounds are required to penetrate. Okay, that's called as standard penetration test. And according to that, according to the results, we are finding out the bearing capacity of the soil, strength of the soil, and other parameters of the soil. So ultimately, summary is that any of the method if you are going to adopt, ultimately the thing is that we would like to know what is the capacity of the soil. And as I told you, based on the importance of the structure, the methods of the soil exploration is going to be adopted. So all these methods are actually present here. You can read it out on your own, okay, and then you can understand. But here I would like to have your concentration over the plate load test, because this is the most common method of soil exploration where adopted. It is good for the normal structure and important structure also. Okay, but when the importance or suppose you are going to give a lot of importance to the project, then in that situation you can go with the any other method. But this is what plate load test is common one. It is for the moderate importance, and for the more importance for every it is going to be set for this. So right, so conducting test on the site to measure the bearing capacity of the soil directly through this method, plate load test. The good thing is that you can calculate the bearing capacity of the soil directly under the anticipated load, anticipated foundation location. Actually, see, sometimes what is happen, it is a very important thing to decide at what point is needed to do the soil exploration. Like suppose for an example, I am giving a very big area. For an example, I am asking you to do the investigation for a very big area where this is my property line, is my property line over which I am going to build my structure, very big structure, very big hotel I am going to build, multi-story hotel, and office commercial floors will be there, offices will be there, so it is a total commercial building. So in that situation, the important thing is to find at what point is needed to do the soil exploration. As I told you, the soil exploration is not an economical approach. It demands a lot of expenses, lot of money is required to do this soil exploration. If suppose you are going to do the deep investigation, then it's very very costly. So like suppose if a very big area is there, and I'm asking you all guys, at what point I need to do the exploration? Can you answer me? Suppose my building is what, like this. This is my complete building, outline of my building, and this is my property line. So can you suggest me at what point we need to do the exploration? Four corners, okay. That's what very true, very correct. At four corners we need to do the soil exploration. At every 100 meter square, that is also what, okay. But if suppose I'm limiting you to do the exploration only at 4 points, okay, except avoid four corners. Yeah, four corners we need to do, and center also we need to do. Except of these four corners and center, where you will recommend to do the soil exploration? Okay, 5 points, okay, done. Where you will take the sixth point? Building area, no. Near property line, no. What is the objective to do the near the property line? Actually, my building is going to be built. This is the outline of my building. What is the scope of doing the investigation here? No use, no load you are going to put there. So why you are going to test the soil? Actually, the very very important thing is that sometime when there is what the concern of the economy is there, then the reverse approach will be there. Firstly, there is a asking to design engineer to do the modeling, to do the analysis, and after analysis, where the geotechnical engineers are asking at what point the maximum load is coming. Sometimes what is happening, the geotechnical engineers are asking with the structural engineers to do the modeling, because plan is already ready, and it is also what finalized at what point the end corners will be, everything is what set. So what's the problem? The structural engineer is going to do the modeling. After the modeling, like suppose this is my building, suppose one column is coming here, one column is coming here, one column is coming here, one shear wall is suppose for example coming here, right? So what structural engineer will do? Okay, this is the column, so at four corners you are all suggesting to do the exploration. Yeah, that is correct. As per the our structural configuration, that is what, okay, columns are coming at four corners, plus geotechnical approach is what, over the proposed area at four corners there is a recommending to perform the soil investigation, plus at the center, so that we can predict entire area where is going to be covered. But sometimes what is happening, when suppose there is a more concern of the economy, then in that situation what is recommending, where the architect or site engineers or geotechnical engineers, they are asking with the structural engineers to do the modeling, to do the analysis, and then suppose these are the columns, these are the shear walls, suppose one shear wall is coming here, okay, suppose the one column is here, and asking to do the analysis. And after the analysis, they are asking what is the maximum reaction. So for an example, okay, here the maximum reaction, here the maximum reaction, here the maximum reaction, here the maximum reaction is coming, okay, taking. But in addition to this, the 6 point at the center suppose also going to perform. They want to know the 6 point. So at the 6 point, they are going to check where the maximum gravitational load or point load is coming. Suppose this is the point, so they are going to choose this point for the sixth bore hole. So this is the one approach in a critical situation. This practice were taken by the practitioners. So this plate load test is what under anticipated foundation location. So means it is what finalized position of the foundation. And when you can decide the finalized position of the foundation, after having the final position of the column. Under the column you are going to put your foundation. So how you will get the final foundation position? After having the final column position. And how you will come to know from the column position? From your architectural drawing, from your model. Okay, so under the anticipated foundation location plus anticipated loading, then we are going to do the exploration, right? So this helps to determine if the soil can support the building loads. Okay, means after doing this pellet load test, we will come to know whether our soil is capable of carrying the load or not. So all the methods are actually listed here. You can go through it, and some other methods may also you may find after looking at the different books. Okay, so you will get. So I tried my best to cover all the methods. Now we have to focus over the plate load test. Why I am giving the importance to plate load test? Let's try to understand. The plate load test is like a real world simulation to see how strong the ground is for the building on. Setup, we place a big steel. Okay, in a plate load test, it's a very simple approach. We are going to do the dig a test pit. We are excavating the soil from the area. We are looking the form strata. Okay, wherever we are getting the form strata by the visual inspection, by the visual understanding, we are going to find out, yeah, this is the layer where I can do the test. This I found that it is by the just visual inspection or visual, I can understand by just looking at this layer, I can understand, yeah, it is the hard one. But I want to know the exact bearing capacity, exact settlement. I want to know everything at this level. So I am going to do the plate load test. And in that, it is a very simple procedure, very simple, straightforward procedure is there. We are going to take a plate. So it is a BP. It is actually what? Thickness of your, width of your plate. And by the similarity, width of the plate directly proportional to equal to your footing width. So we can relate the result coming for this steel plate with your actual foundation width. So that is the another point of discussion. But as of now, we have to understand what we are going to do in this method. So simply what we are going to do, we are going to put a steel plate. A steel plate, maybe most of the time it will be square of equal dimensions, and sometimes maybe a circular one, and the thickness may ranging from zero point 0.3 meter to 0.75 meter, means 300 mm to 750 mm the size of the plate will be there. And most common size normally we are taken as 450 mm by 450 mm square size of the plate, right? And over that we are going to do the setup where we are going to apply the load over this plate by the hydraulic jacks. By the normal loading or by the hydraulic jacks, we are going to apply the pressure over this steel plate. And at these four corners, not three, not two, minimum four recording gauges are actually going to be set at four corners of the plate. And through this system, we are going to apply the pressure over this. I can show you here. Yeah, see. So here we are going to record the settlement at four corners of the plate. What settlement is going to be done, and we are going to continuously increasing the pressure. So here we are increasing the pressure, load we are going to increase, and from here we are going to see the settlement. And against these two, we are going to plot a graph, loading or pressure and settlement, and to a what extent we are going to apply the pressure. So normally we are going to do this testing up to a maximum of 25 mm settlement. We are going to increase the pressure continuously, and according to increase of that pressure we are going to measure or we are going to recording the settlement. So it is the plot of your loading and your settlement, and it's quite obvious if you are going to increase the pressure, settlement is going to increase it. So this is the role of this plate load test. By doing this, we get the graph that shows us how much the weight that the ground can support before it start to sink too much. If the settlement is going to exceed beyond of 25 mm, we will stop our pressure. We will stop our application of the loading, increase of the loading, and that will be the maximum capacity of the load that your soil can carry up to a 25 mm settlement. So this helps us know if the ground is strong enough for the building a stable foundation or not. So this is what soil investigation with a plate load test. So why I am discussing this point in detail? Because we have to importantly discuss about the soil subgrade reaction or soil subgrade modulus. This is the most important part of this discussion. Actually, soil subgrade reaction we need to know, and this property and this factor will not directly come. Actually, soil subgrade reaction is actually the simple thing. It is the stiffness. If suppose you don't want to call this as soil subgrade reaction, soil subgrade modulus, okay, call it to as simply as stiffness. As we are talking about the stiffness of your concrete, as talking about stiffness of your steel, likewise your soil is also having the stiffness. And what is the stiffness? Stiffness for any of the material, whether it is concrete, whether it is steel, whether it is your soil, whether it is rubber, whether it is wood, whatever the element, every element will have some extent of this, it's a stiffness. So what is the stiffness? Stiffness is nothing but the resistance to deformation, and the soil subgrade modulus is the same thing. So soil subgrade reaction, soil subgrade modulus, often referred to as a K, modulus of subgrade reaction K, is a measure of the stiffness. As I told you, what stiffness? Resistance to the application of the loading. What is the capacity of the soil to resist the load without of undergoing any settlement? Like soil is going to be subjected to the vertically downward load. Suppose this is my soil layer. For an example, this is my layer of the soil, okay, and over that I am going to put the load. So to what extent your soil is what resisting this load and is not going to experience any failure or any settlement. But if the load is exceeding beyond the capacity of the soil, as the most common case, because soil is not having that much stiffness as in comparison of your concrete, as your comparison of your wood, as in comparison of your steel, soil is what is the accumulation of the particles. They are in actual, not in connected form. If you are going to consider a wood, if you are going to consider a steel, so all the particles are collected with each other. But when you come to talk about the soil, so soil is not in a connected form. So soil is not having that much stiffness. It's all depends on its compactability. How much the compactability is there, accordingly soil is going to exhibit the its strength against your loading. So soil का आपको उतना स्ट्रेंथ नहीं मिलेगा, इसीलिए हम लोग क्या करते हैं, वॉट एवर द लोड कमिंग फ्रॉम द कॉलम, आई एम गोइंग टू पुट दैट कॉलम, आई एम नॉट गोइंग टू डायरेक्टली पुट द कॉलम ओवर द सॉइल. यू मे रेज ए क्वेश्चन, सर व्हाई इट इज नीडेड टू प्रोवाइड द फाउंडेशन. फाउंडेशन प्रोवाइड करने की क्या जरूरत है? डायरेक्टली हम लोग सॉइल को इतना स्टीफ बना देते हैं कि डायरेक्टली हम लोग कॉलम को सॉइल के ऊपर रख देते हैं. व्हाई इट इज नीडेड टू प्रोवाइड द फाउंडेशन? इज इट द क्वेश्चन और नॉट? फाउंडेशन देने की जरूरत क्या है? व्हाट इज द नीड टू प्रोवाइड द फाउंडेशन? मैंने कल भी कहा आप लोगों को, फाउंडेशन इज जस्ट ए प्लेटफॉर्म टू गिव टू द कॉलम. अल्टीमेटली द लोड इज गोइंग टू बी ट्रांसफर टू द सॉइल. ओके, ऐसा भी नहीं है कि हम लोगों ने फाउंडेशन दिया तो अब लोड सॉइल के ऊपर ट्रांसफर नहीं होने वाला है. दैट इज ऑल्सो नॉट द केस. अल्टीमेटली लोड तो सॉइल के ऊपर जाने ही वाला है. सो व्हाई यू आर गोइंग टू पुट योर फाउंडेशन? So actually we are distributing the load over a wide area. Column is carrying a point load, और वो point load को हम लोग क्या कर रहे हैं, convert कर रहे हैं as a aerial load. उसको हम लोग क्या कर रहे हैं, we are distributing over a large area. Why? Because your soil is not having shear resisting capacity. आपका जो point load आ रहा है, that is acting as the shear load. That is what? Acting as a shear load. और आपको मैंने अभी जस्ट कहा, सॉइल इज अक्यूमुलेशन ऑफ द पार्टिकल्स. पार्टिकल्स का समेशन है, और वो समेशन भी मीन्स डिसकनेक्टेड फॉर्म में है. ओके, इफ यू आर टॉकिंग कंक्रीट, सो कंक्रीट इज अ यूनिट. इफ यू आर टॉकिंग अबाउट द स्टील इज ऑल्सो व्हाट इज अ वन मटेरियल. But soil is not entire one body. That is what accumulation of the small particles, and even that particles are not in a well compacted form, in a well connecting form. So इस वजह से क्या है कि हम लोग यहाँ पर डायरेक्टली कॉलम को नहीं रख रहे हैं. और कॉलम को अगर रखेंगे, दैट इज सडनली योर सॉइल इज गोइंग टू फेल इन shear. Soil suddenly fail हो जाएगा, your column gets sinks down. Okay, for an instant I am going to say your soil is not having shear resisting capacity. That will also be the right one, है ना. जब आप क्लेई सॉइल की बात करेंगे, ओके, लूज सॉइल की बात करेंगे, इन दैट सिचुएशन सॉइल इज नॉट हैविंग द shear रेजिस्टिंग कैपेसिटी. उसमें जो लोड आ रहा है वो उसको रेजिस्ट ही नहीं कर सकता है, सडनली सेटल हो जाएगा आपका कॉलम. It means that your soil is not having shear resisting capacity. But yeah, if you are going to do the compaction, okay, you are going to take the measures and you are compacting to a great extent, then at that time to a some extent your load will going to be carried by your soil. But फिर भी आपने बहुत ज्यादा किया और contact surface को बहुत कम किया. If suppose you are going to reduce the contact surface between your vertical element and your soil, then in that situation your column gets sinks down. Whatever the load you are going to put, that is going to be sink down and your soil is going to fail in shear. So stiffness is what? Resistance to this application of the loading and maintaining its deformation, is not undergoing to the deformation. So what subsoil, often referred to a K or modulus subgrade reaction as K, is the measure of stiffness or resistance of the soil beneath the foundation. फाउंडेशन के नीचे जो कैपेसिटी है वो हम लोग मेजर कर रहे हैं. इट रिप्रेजेंट हाउ मच द सॉइल कैन रेजिस्ट डिफॉर्मेशन अंडर द गिवन प्रेशर फ्रॉम द फाउंडेशन. सो अब यहाँ पर हम लोग उसको एज अ प्लेट से ट्रांसफर करते हैं लोड. दैट्स व्हाई इट इज गोइंग टू बिकम प्रेशर. If you are going to apply directly the column, so it is going to become point load. If you are going to put over the plate, now it is going to be converted into aerial load, and that aerial load we are going to call it as pressure. So it's quite obvious that if you are going to increase the pressure, settlement is going to increase. So here, as you can find from the graph, जैसे जैसे आप pressure increase करेंगे, your settlement is going to increase. So actually we are going to this plate load test, and this plate load test will help you to find out this soil subgrade modulus. Because to calculate the soil subgrade modulus, we are going to follow this equation. So this plate load test will help you to do the calculation for the subgrade modulus. So subgrade modulus is the ratio where you have to take the pressure value, whatever the load you are going to apply, over a what area you are going to apply, and settlement, what settlement is coming. Based on that you will get this soil subgrade modulus. Now the question is that why we are focusing on this soil subgrade modulus, why we are giving that much importance to this soil subgrade modulus. Actually, when I'm asking you to do the design of your superstructural elements, it's a question with you all guys. Just let me know if I'm asking you to design the superstructural elements like beam, column, slab, as let's say shear wall or any other elements, whatever we are going to consider in the superstructure. So what you will do, you are going to create a model for that. Am I right or wrong? You are going to apply the load, then you are going to do the analysis, then after doing the analysis you are going to find out the stresses in the member as the axial force, as the bending moment, and a lot of things you are going to find out, and accordingly you are going to do the design. But have you practiced the thing where in a substructure you are going to model the soil? Have you seen anywhere? Actually that should be done. For the substructure, what we are calling the foundation and subsoil as combinedly going to form the substructure. Your foundation is not actually the substructure, your soil and foundation is going to become your substructure. Okay, so in actual we should model the soil for our proposed land, for our proposed structure. But there's no scope, there's no availability to do the modeling for the soil. So that's why we are going to relate it with the spring concept. We are going to implement the spring concept, and that spring concept is what? If spring you are going to consider, if you are going to apply the load in respect of your application of the loading, your spring is going to be get deformed. When you remove the load, spring get attains its actual shape, right? So it is what, to instead of modeling of your soil, we are going to idealize it in the form of the spring, and your K you can also call it as spring constant, right? So in spring constant is again the stiffness, and stiffness is what? Resistance to deformation. But for the case of the spring, we are talking about the point load. But for the case of the foundation and subsoil study, we are going to apply the aerial load. That's why this term is going to be changed as pressure means aerial load divided by settlement. And by implementing this property, we are going to consider the soil behavior and soil response, because in actual we cannot model the soil. So for that reason we need to consider this K factor, soil subgrade modulus. And when you are going to practice in the CSI safe software, there we have to define this property as soil subgrade modulus, which is we are going to idealize for our proposed land. हमारा जो लैंड है, हमारा जो प्रपोज्ड स्ट्रक्चर है, उसका बियरिंग कैपेसिटी जो हम लोगों को मिला है, उसको क्या करेंगे हम लोग? इट इज व्हाट? इट इज अल्टीमेटली द बियरिंग कैपेसिटी ऑफ द सॉइल. ये हो जाता है आपका एसबीसी ऑफ द सॉइल, and divide by SBC means force per unit area, and divide by allowable settlement, कितना settlement allowed है, and that value will give you stiffness or soil subgrade modulus. And that we are asked to consider the soil property in your CSI safe software in the section of the define spring properties. यहाँ पे देखिए we are going to idealize it as spring, what I told you, as a spring. There is a theory, okay, one scientist has actually idealized this soil behavior by relating it with the spring. Okay, I'm not able to recall that scientist name. Okay, so here it is what? Area spring. If that you are going to impose the load over the soil by area, हमने क्या किया, यहाँ पे कॉलम को प्लेट के ऊपर रखा और फाउंडेशन के ऊपर, and from through this foundation it is going to be transferred to the soil, so it is going to become area spring. If you are going to consider a line element like beam, and through that beam you are going to impose the load to the soil, it is going to become line spring. If you are going to consider deep foundation and you are going to transferring the load carrying from the above ground to a greater depth through the tip, through the point of the bottom point of the your pile, so that comes under the point spring. So based on the contact surface and the load transfer through that surface, the spring constant or soil subgrade value you have to define here. So if you are going to consider the point load transfer, so point spring means very small area is going to be connected with the soil mass, so it is a point spring. If you are going to consider line element like beam, so you have to consider the line spring. If you are going to apply the load over the soil through the area, it is going to become aerial spring or aerial stiffness. And here line is stiffness, here the point is stiffness. So this is what, that's why I'm giving the importance. So these all properties we have to define, then it means that we are going to consider the property of the soil. So in the CSI safe software, nothing we have to set only except of this soil subgrade modulus. So at that time I will explain how to do the calculation, how to define in the software, everything I will discuss at that time. One more important thing, actually if you are going to talk about the soil, so soil anyhow we cannot avoid the settlement in the soil mass, because if suppose you are going to apply the load, so settlement anyhow is going to be happen, because as overall your soil mass and earth surface is a natural, so we don't have that much scope of the control. So that's why we are allowing this settlement. Actually if overall response of the soil is in our hand, as for the other elements like concrete and steel, so what we will say, we are not going to allow the settlement, but actually that is not in our control. That's why we are allowing some extent of the settlement in the soil mass under the application of the loading, but that settlement should be uniform. If your entire structure is going to be settled, if your entire building as uniformly from the base level is going to settle, suppose the base of this building here and here, okay, this is the one building, okay, this is the connected beams and columns whatever and floors are there. Under the application of the loading, if the soil is fails to resist the load which is coming, so what, this building will get settled down, but that settlement should be what? Uniform. This building gets settled like this gets settled like this, so base of the column should be at the same level. So I will say that this is a uniform settlement, and that is what acceptable, because the entire structure is going to settle, so that is not going to lead the complete collapse of the structure, complete failure of the structure and great damage to the structure, that is not going to lead. But my dear friend, in a situation when you are having the unequal settlement, like one point is going to be settled more, another point is going to settle less, so your building is what going to experience more damages, more cracks will be in your foundation, in your beam, in your column, and that may also become a cause of complete collapse of your structure. That's why what the settlement anytime for the structure we are going to consider as a uniform settlement. Non-uniform and unequal settlement is not acceptable. So for the different types of the structure, as for the shallow foundation we are allowing some settlement, for the deep foundation we are allowing some settlement. So for the normally shallow foundation, remember, note this point, 25 mm to 50 mm the settlement is allowing, and for the deep foundation that settlement where is going to be allowed from 5 mm to 12 mm. And this is not the fixed one, I am just giving the general value based on the experience. After having experience of many soil investigation report, study of the soil investigation report, so for the concern of the shallow foundation, the allowable settlement were suggested by the geotechnical engineer as from 25 to 50 mm. But when you come to talk about the deep foundation, that is what ranging from to 5 to 12 mm. So it is not the fixed one. Again, it's all depends upon the testing. After the test, we are going to get the settlement values. Okay. For the deep foundation, we are going to find out the firm strata at a greater depth. So already we are ensuring the very firm strata, so there are least chances of the settlement. That's why we are going to permit minimum settlement. So hope that's all clear to all of you about the settlement, soil subgrade modulus, its importance, methods of the soil exploration. So summary of all this discussion is that we need to have the detailed understanding of the soil, and once you got all the properties of the soil in respect of its moisture content, it's in respect of its permeability, in respect of its plasticity, in respect of its bearing capacity, ultimate bearing capacity, in respect of its resistant potential, and if it is not having that much potential to resistance, it is undergoing for the settlement. After having all that study, and lot of things are also there, if you are collecting all that data by adopting one or number of methods of the soil exploration, you have to prepare a final report. This all information should be properly documented to submit to the architecture or the structural engineer, obviously, because if you are in concern with the architect, so you have to submit the report to the architect, or if you are directly in connection with the structural engineer, so you have to submit the report to the structural engineer. It depends the structural engineer from whom it is getting the task or job. Okay, so they have to submit this report to that person, and ultimately that report is going to be used by your structural engineer to do the design. So that detailed documents, that detailed information is nothing but your soil investigation report. So all the data that you have collected by explorating the soil mass, and after collecting all the information, all that practices from visual inspection to final getting the results, all that you have to document properly, and that document is nothing but your soil investigation report. Now you have complete clarification what will be in your soil investigation report. Nothing but your the things that you have executed, आपने जो चीजें किया है, क्या मेथड आपने अडॉप्ट किया है, फॉर व्हाट पर्पस, for what building, for what structure, for what location, with what methods, with what parameters you are going to find, and what your findings, that all you have to write and have the detailed document for that, and that document is termed as what? Soil investigation report. So I am going to further summarize what will be the content of your soil investigation report. अब उसको हम लोग प्रॉपर वे में लिस्ट आउट करेंगे कंटेंट को, एंड वी आर गोइंग टू प्रेजेंट इट टू द स्ट्रक्चरल इंजीनियर, means it is coming to us for the designing of the foundation. So section 1 of the soil investigation report will have the aim, for what purpose you are going to execute the soil, किस पर्पस के लिए आपको सॉइल को एग्जीक्यूट करना पड़ रहा है. ओके, और व्हाट इज द स्कोप ऑफ द इन्वेस्टिगेशन, क्यों कर रहे हो आप, what is the definition of the प्रोजेक्ट, लोकेशन ऑफ द प्रोजेक्ट, सारी चीजें आपको यहाँ पर एम एंड इंट्रोडक्शन गिविंग द स्कोप ऑफ इन्वेस्टिगेशन में मिल जाएगा। किसी भी आप सॉइल इन्वेस्टिगेशन की रिपोर्ट को देख लीजिए, द टाइटल में गेट चेंज, ओके, बट द थिंग्स विल बी सेम। देयर विल बी व्हाट डेफिनेशन or information of your project. It is G+5 floor building, it is located in that area, the owner may be written, who is going to investigate, that may be written. Okay, general information introductory part you will find in the first section. In the second section, what methods they are going to adopt, what strategies, you can call it to a methodology, what parameters they are going to focus to investigate. They are going to focus for the shearing capacity, they are going to bearing capacity of the soil, they are going to see the water level. Okay, what parameters they are going to mainly focus, and what methods, either they are going to do the field testing, site testing, they are going to do, they are going to the laboratory testing. Okay, in field testing, what methods they are going to adopt, in laboratory testing, what methods they are going to adopt, what parameters they are going to focus in the laboratory testing, what parameters of the soil they are going to test in field test. Some of the parameters that cannot be tested in the laboratory, some of the parameters of the soil cannot be tested in the field. So that's why if both of the methods we are going to be adopted by the geotechnical engineer, so we are going to be considered by the geotechnical engineer. Okay, both of the methods, so that will be written here directly. The geotechnical engineer is not going to suggest this is the property, this is the capacity of the soil, this is the allowable settlement. No, everything will be what in written format, what strategies they have followed for the inspecting the soil and proposed land. That all you will find in the field test and in laboratory test, and in methodology, what methodology they are going to adopt. And the third section is the discussion of the subsoil conditions. Now, after doing the field investigation, after doing the laboratory testing, okay, they are going to discuss on the results in the fourth section, discussion of the subsoil condition after doing the test. So this is the heart of the report, and should be clear and concise. Means whatever the findings of site and laboratory testing, that should be discussed in this section in detail, and that will obviously be present in your soil investigation report. And that should be concise, that should be what, simple and clear, and in the short form it should be to discuss important things. Okay, it is reported under the following subhead: description of the soil condition as evaluated from all the field and laboratory test. After doing the laboratory test and field test, what are the findings, analysis and discussion of the field and laboratory test results, discussion has needed to do, then discussion criteria like allowable settlement to be used. Now this will give you the calculation for the allowable settlement, what allowable settlement will be suitable, calculation for determining the bearing capacity of the soil. There are different methods to do the calculation for the bearing capacity of the soil. As you can see, Prandtle's theory for the shallow foundation to do the bearing capacity of the soil, Terzaghi theory for the bearing capacity of the soil. So by implementing the equations, and after finding out these all parameters, where the geotechnical engineers going to choose any one approach to do the ultimate load carrying capacity of the soil. So what method, what theory they have adopted, and what calculation they have done, everything will be written there in their report. So in a detailed format, in this section 4, they are going to recommend what type of foundation will be more suitable. And they are also giving the allowable bearing pressure, slope stability, ground improvement options. Okay, they are going to suggest, plus recommendation of the soil parameter for the structural design. So here they are going to do the overall discussion, what they have done, what their findings, and based on their findings they are going to do the recommendation, that here it is written now. So they are recommending the type of the foundation will be suitable. They are giving the different options also: shallow foundation, deep foundation. In shallow, either pad footing will be there, combined foundation will be okay, raft foundation will be more feasible. If you are choosing the raft foundation, so what will happen? If you are taking the pad foundation, will what will be happen? So that all discussion will be there in the discussion section. And last and the most important is what, conclusion and final recommendation. Here it is what, discussion, and based on that discussion they are finally concluding the things with a final recommendation. So they are recommending that what type of foundation will be more suitable, This last part of the report should give the definite recommendation based on the field and laboratory test results. So what type of foundation you should adopt for your project will be given, plus they are also recommending what method of excavation, what method of execution should be adopted for the safety purpose, that also they are recommending. For an example, on a proposed land, the geotechnical engineer has noted the ground level, means if your water level is close to the ground surface, so in that situation what will be the challenges at the time of the execution for the foundation. Actually I have added here effect of groundwater level. So foundation design, if suppose at the time of doing the investigation they found your water level is close to the surface, in that situation what will happen, based on that they are recommending the type of foundation. Actually soil is having the capacity to resist the load, soil is having the adequate bearing capacity, but due to the presence of the water level close to the ground surface, what problem will be there, and due to that problem what type of foundation is going to be changed. So the depth and fluctuation of the groundwater level directly influencing how deep foundation need to be. If your water level is near the ground surface, at the same level, if suppose you are going to propose the foundation, so lot of challenges will be there. Like what, at the time of the excavation, at the time of the casting for the concrete, for the foundation plate, for the foundation slab, continuously you have to maintain the dewatering arrangement. Whatever the water is coming, you have to dewater that. That is the one challenge, that is increasing the cost of the substructure. Foundation must be anchored below the groundwater table. So if the water table is getting near the ground surface, so geotechnical engineers are suggesting to take the foundation depth to a greater below the groundwater level, means this water level they are recommended to take the foundation to a greater depth, so that it is not going to impact your foundation. For an example, if the groundwater level is high, shallow foundation may be at risk of instability and excessive settlement due to water saturation, because means saturation will be there, that is going to create the uplift pressure, plus what this kind of excessive settlement possibility will be there, because the soil is going to become loose. That's why we are going to a greater depth to find a firm strata. जब तक आपको हार्ड स्ट्रेटा नहीं मिलता है फिर हम लोग वहां पर पुट करेंगे, एंड देयर इज नो इम्पैक्ट ऑफ any water through the surroundings. Excavation and dewatering, as I have discussed, if you are going to build for a deal a situation where the water is close to your ground surface, so there is a problem to dewater continuously at the time of the excavation and at the time of the casting for the foundation slab. Material selection, depending on the groundwater level, material used for the construction must be resistance to moisture and water increase. For instance, in areas with high groundwater, concrete mixes may need additional waterproofing additives or membranes to prevent water penetration into the structure. So in that situation you have to choose the material, dense materials you have to choose, so that the penetration of the water should not be there in the area. So this is all the impact of your water level, and that also we are going to be measured by the geotechnical engineers. And if that kind of situation will be there, that is going to be written in your soil investigation report, वो भी आपको रिपोर्ट में दिया रहेगा. So water level will also be given, and finally conclusion and final recommendation will be there. Okay, so this is all about your soil investigation report. So hope you may be interested to see the real soil investigation report. So have a look over this real soil investigation report, the soil exploration report, soil investigation report. Some confidential data I have hidden. Okay, so project name, as I told you, project name will be there, location will be there. Okay, and which company is going to do the investigation, that will also be written. Which senior engineer, geotechnical engineer, junior geotechnical engineer has going to execute the site, that also will be written. Okay, every information is specifically for your project will be given here. Then index will be there. Okay, content index will be there. Thereafter introduction, as I told you, introduction part will have the purpose and scope, for what purpose you are going to aim purpose means your aim, and the scope for what you are going to do, that all where it is written. Okay, you can read it out. And then site location, what number of floors of buildings, what type of building is there, that will also be the written. Field investigation, what methods they are going to adopt, standard penetration test, rotary boring they are going to do, laboratory testing they are going to do. In laboratory testing, what parameters they are going to focus, as I told you, specific gravity, sieve analysis, Atterberg limits, means plastic limits, plasticity, and natural moisture content, permeability, everything we are going to do in the laboratory test. That is not possible to do in on site. Okay, thereafter soil profile. Okay, after doing the investigation, they are going to give the soil profile. Okay, this is the soil profile that will be given. I will come to this point first. In the last, we will have the recommendation. As I told you, recommendation will be there, final discussion and recommendation. So in the recommendation, what they are suggesting, the isolated footing is recommended for this project, for this site, for this project. Which type of foundation they are recommending? They are recommending to use the isolated footing. Rest, the foundation, at what depth we have to put our foundation? At a depth of 5 meter below the natural ground. People are asking, sir, at what depth I have to put my foundation? How I will come to know? So this soil investigation will recommend that. Sir, what type of foundation we should choose? That also we are going to be recommended by your soil investigation report. Sir, what is basis of the soil I should choose, I should consider? That also will be given your soil investigation report. Now the detail is BC at every 1.5. Here it is what, directly at 5 meter, what the bearing capacity they are getting. But if suppose you are asking, sir, I'm not willing to go at this depth. Okay, they are recommending, this is what recommendation. If you are having the confidence and experience, so by using this report you can choose another depth. So they are giving the SBC of the soil at every 1.5 meter interval. And as quite obvious, if you are going deep, the SBC is going to increase. You will say that, sir, I will put my foundation only at 4 meter depth, I am not willing to go at 5 meter depth. So it's okay. What to do? Go to the find this detailed report, the detailed SBC of the at every 1.5 meter below the ground, below the natural ground. They are going to test at 1.5 meter, then 3 meter, then 4.5 meter, like that. So what I'm going to do, I'm going to see that detailed calculation, references, what codes they have followed. Okay, Indian standard codes, what codes they have followed, that all given here. Now this is what the report from 8 to 12 or 12 to I think 19 they have recommended. Let me show you. Yeah, see, standard penetration test, and at a depth of 1.5 meter, observed in number of values, number of blows, how many number of times you are going to hit. Okay, if you are going to do the study the standard penetration test, then you can understand the concept. So don't worry about this, forget this, just focus on this. 1.5 meter depth, what is the bearing capacity? 35.8. How to convert it into kilonewton per meter square, I will explain it later on. But as of now, just remember, just multiply it by 10. So 358 SBC. I will explain in detail. Okay, don't worry. Then at 3 meter depth, it is what? 368. At 4.5 meter depth, 379. So as you can find, as you are moving from top to down, the SBC is increasing or decreasing? Okay, it is what? Increasing. So यहाँ पे आप कहेंगे, sir, I will take my foundation only at 3 meter. So your SBC will less, and accordingly your size of the footing requirement will be more. But if you are going to greater depth, so 410, and here 368. If SBC is less, area demand will be more. If SBC is high, area demand will be less. Both are vice versa. So in this way, detailed reports are actually given here. So this you can read out on your own in detail. Okay, and some pictures they are going to add for the borehole, and they are finally giving the site location by plan, by the figure, and at what point. This is the site, this is the building, overall building outlines. They are going to build their structure, and for that they have chosen this line to do the investigation. They have taken 4 boreholes, or for the test points. So this is the first one, this is the second one, this is the third one, this is the fourth one, and for all boreholes, they have given the detailed report. Borehole number 4, borehole number 3, borehole number 2, and borehole number 1. Because the people are actually very much in confusion that what does the soil investigation report and all. So I tried my best to summarize the complete geotechnical engineering in a short way that is actually required for our study.